Hello, it's David. Today I'm going to have a look at my Falcon PSU. This is my original unit from 1992-93. I've never had any problems with this, but I decided that given how old it is, and one of these capacitors here does look like maybe we're just starting to see a little bit of a bulge. Very slightest hint on this one that it's time for a recap. I bought a capacitor kit from the Exxos store, links below, and this is what you get delivered. Exxos puts all of his instruction manuals on his website, so this doesn't come with a paper manual. So we have 16 volt 1500 microfarad capacitors times 3. These are can't see the make on these. 1500 times 3, 123. That will almost certainly be those. We have 3 Rubicon 35 volt 47 microfarad capacitors, which will be 1, 2, 3, I would guess. I'm not sure what that one is. That is a 25 volt 22 microfarad capacitor. So it doesn't look like we have a replacement for that, but hopefully that's in good working order. We have a very large 400 volt 47 microfarad capacitor, 400 volt 33, so that's an increase on the main one there, and this is a Nippon Chemicon. And we've got a replacement rectifier. Now that's replacing this little part you can hopefully just see down in there. The pin out from this one and the original is slightly different, so we've got to be very careful with our pin positioning there, and to make sure that these don't short out. So my suggestion is that I will place some heat shrink on the legs here to make sure there's no short circuit. Now, as I say, I've not had any problems with this power supply, but just out of interest I thought I would put it under a mild load. I'm not going to go for a full I think this can go up to like 2.5 amps. I'm not going to go for a full load, but we'll go to a 1 amp load and we'll have a quick look at the ripple. But because that will involve working on this with the mains connected, I've made myself a little protective cover. Just a 3D printed case, which is designed to fit over here and screw in here and here. I'm not going to screw it down, but I will load this up just to stop a little bit of accidental fingerage. Not the most perfect fit with the screws in, but stops the majority of problems there. So the 2 rails produced by the Falcon's connector are the 5 volt rail, which is the red, the 12 volt rail, which is the blue, and then the other 4 pins ground. So in order to measure the output of here, which is a can't remember the type of connector, I do have some connectors like this and I want to make an extension. These are, I think, a type of Molex. But what I'm going to do is to take some broken off pin headers and just jam those in to provide a connection. So one on 5 volts, one on ground, nice and far apart. It'll just give me something to measure. So obviously no point measuring it when there is no load on it. So what I have here is a little homemade electronic load using one of Dave Jones's concepts. And it's quite simple. Power in here, battery here, potentiometer here. This measures the voltage drop across a 1 ohm resistor to give you the current that's being dissipated, and there's a heatsink in there and a big old MOSFET. So I should be able to connect this up to here. Now what we're really interested in is ripple. So what I'm going to do is get out my oscilloscope and I will measure across. So we're going to set the oscilloscope to 1 volt per division. Move our ground down here, so we're expecting 1, 2, 3, 4, 5. That should fit on. Maybe we'll just go to that. Maybe we'll just go to that bottom one there. So we should fit happily on the screen. Okay, the mains. Okay, right. Straight away you can see we're drawing just over an amps current, and we have some noise here on the oscilloscope. Anyway, we can see it's approximately just over half a volt ripple at, call that about 10 microsecond period. So let's get on with the recapping and we'll see if we can improve that. Okay, so the power is off at the mains, and we've let this stand for a couple of seconds. I'm going to remove my protective shield. Oops, I lost one of my header strips. Go and look for that in a minute. Right, so the big danger here is obviously stored power in one of these big capacitors. I'm not too concerned, I'll be honest. I think that the safety draw-off is quite good on these, but just for complete peace of mind, I'm going to jam a electrician's screwdriver in there, short those terminals out. Okay, so first things first, we need to get the board off of the chassis. That one appears to have the ground connection as well, so that's quite important. Now I'm still going to be a little bit careful here, because I still don't 100% trust that that capacitor is discharged, but it'll be easier for me to make sure of it now. Flop this over and use a big screwdriver on it. This, by the way, is not the way you're supposed to discharge it. It should go through a resistance, but I think we can be quite happy with that. There's a big old reefer style capacitor on it here, which should, I suspect, go to earth. Let's just make sure that that one is suitably grounded too, although I can't see which terminals are. Anyway, here we are now. Right, so we'll unclip the power lead. the chassis for later. And this is on my dissipative earth mat, so as all those terminals touch the mat, should again be further safety shorting. Okay, so time to one up the soldering iron. Now when I do my SMD work, I prefer a K-tip. This I think is very useful for soldering quad flack packs and individual 0803 I think is what I normally do, capacitors, resistors, etc. But for through hole, I don't think it's a lot of use. For through hole, I prefer the chisel tip or screwdriver head. It's a reasonable combination of precision and point precision and heat delivery. So I'm going to start with the big one. So negative side to the blue silk screen on the board. And I'm going to put my iron, since I'm doing through hole work, up to about 315, and we'll see how we go from there. A little bit of flux paste. Probably the easiest thing to do is to add extra solder. So I'll add extra solder first, and then I'll switch over to using my hand pumped solder sucker. These, if you're not using them very frequently, and therefore would invest in the gun style, are less than £10. They're brilliant value, and as you can see, it's a combination soldering iron with a hole and manual solder sucker. And it is surprisingly effective, albeit a bit crude. So I think I got this one. This is Duratool one. I think I got this from RS. No, sorry, from Farnell. I think these ones. And that's melted very nicely, very quickly. Just put my little fan on. Blow away some of these fumes. It's not done too badly. Looks like there's a bit of a dag on this side. I can see this pin showing a slight wiggle. This pin, nothing at all yet. Now I can see that's melting. I think I've got too good a seal on it. That's done a quite good job there. And we're getting a good amount of wobble there now. Now there's a little bit of crustiness under here. Doesn't look too pretty. Perhaps we are a little late to the party here. Definitely a little bit of crust under here. Wasn't really planning on cleaning this today. But I suppose all the time we're under here, there's no harm. Okay, so negative side to the block blue. Try and thread the arms through. There we go. Then a little bit more flux, because why not? This stuff doesn't last very long, so you've got to use it up anyway. Try not to burn myself on the desoldering iron. Don't have much room in the shed. And a nice amount of solder back on. Good. Worry about the flux residue later on. Yeah, no, that is a bit crusty. So next on the list, we've got these whole bunch of capacitors there. That was a bit loose, a little bit loose actually. Let's take out the larger three first, shall we? Let's get the old cheap Chinese tester on this. See if we can get it in there. So that's coming out with an ESR of 0.13, that's not too bad, 790 mic. And this one is rated 1000, so that's definitely past its best. Not completely convinced with how much heat I can pour into these old PSU boards, so I'm going to go over the top with the desoldering iron. Okay, the top pin there is loose. The bottom one needs a bit more persuasion. Persuasion duly applied. Okay, so this is supposed to be a 330 microfarad. And that's got some crust underneath it as well. 348, 2 ohms though. Yeah, look at that. That's some muck under there. Doesn't look too bad on the cap, but this is the most pronounced bulge. Look at that, just certainly not convex. Sorry, concave, is it? But then have a look at the crust that's left behind there. I don't have my fiberglass pen to hand, and it's only a power supply, so I'm not going to worry too much about that, but I think that's now clean enough. So we are short one capacitor. These are 47 microfarad ones. And according to Exxos's documentation, we shouldn't be short a capacitor. Oh dear. Double check the box. Okay, we're down a cap. So C14 I just took off there. The worst one of the bunch is a 330 microfarad capacitor. Which is the very one I don't have. Damn, that's the one that's missing. Yeah, it says here that one 330 microfarad capacitor being replaced by one 680 microfarad capacitor, which is not in the set. So, unfortunately, I don't have any high quality capacitors of my own. That's why I bought the kit. 333.7 ohms. It is pretty close to what it's supposed to be, but that's a high ESR. What have I got in my box? So he recommends replacing with 680. Would you believe it? I don't have any 680 electrolytics. Right, well I do have some 470s, but these are no-name nonsense ones. This is my 470 draw. These things could be anything. Actually, it's not a 470, it's 4.7. That's a 47. And those are obviously not electrolytics. I don't have a 470 either. This is a reclaimed one. Obviously been tested good. This is a 470 16 volts. 470 16 volts. That's a 25 volt. Not sure that's a good idea. But look at that ASR. That's a lot better. What have I got in the 330 range? Well, I've got a 200 volt. And that might be a bit over the top. Okay, I've got some 330s here. Again, there's 16, level 25. I don't know what sort of voltage that these things are across. The 1000 volt, no, the 1000. The 1000 microfarad ones that I've taken out are only 16 volters. So this might be the best bet. $470 microfarad, 16 volts. Hermay. Never heard of them. Right. She's in nice and tight. Oh dear. That is a mess. Not enough flux. The wonders of flux. I've overdone that, but better too much than too little, I reckon. Just the very slightest bit of standoff there. I think it should be right. So the other three are these, which is the 1500 16 volters. Long leg is the positive side. Short leg to the negative side. Push it through, bend them out. Learn from the previous lessons, get the flux on. Nice blob on my soldering iron. Hold it into the board. Dab into place. Right, so we've got 47s left. So the 47s are 1, 2, and 3. Tell you what, let's desolder them first. Don't get confused. Oops, I missed the legs from that one, previous one. Can't see any legs that I missed. Good, so we've got an awful lot of flux residue to sort out. Keep my spare legs here. And I'm just going to double check the polarity of all of these capacitors that I've put on. So negative, white band negative to blue, 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 negative to blue. So I'm happy with that. This is very messy now. Awful lot of flux residue. So I'll just go over this quickly with some IPA. Rectifier next. So the rectifier in the original is this little square package, and it's quite difficult to make out, but the pins are negative, positive, AC in, AC in. Whereas the modern replacement is positive at the top, AC in, negative, AC in. So we need to do some rewiring. Something like that. So what I propose to do is to put some heat shrink tubing on those legs to protect them. But first, let's get our DB1 off. And we'll just take our smallest possible heat shrink, which I believe is 2 mil. And if I cut each one of these 40, are they 50 mil? 40 mil. Cut each of these in half. I think we should have suitable protection. Oops. So that would stand off from the board that far. Should give me enough soldering room. So we'll power up the hot air station to 160 degrees. And shrink these on. These aren't going to shrink all the way down to grip this. Tightly. They're only 2mm tubes, and they can't shrink down to what I presume is about 0.3mm legs, but they can certainly get a bit tighter. Like that. There. So, that's much easier to see now. See the circle for pin 1, that's the positive. Positive, AC, AC, negative. So let's start with the positive. So the positive and negative, the two ACs have to go at the bottom. Positive, negative, AC1, AC2, try and squeeze those down through the holes. Strain the legs up a bit. There we go. Right, so double and triple check this. So positive. This leg comes down here to the board, marked. Can't quite see that. Marked positive. It's just under that cap. Negative. This leg that comes down here to just next to this cap here, where it's marked with a negative. The other two must then necessarily be the ACs. Try and push that down a bit further so that the heat shrink does its job. There we go. Positive to positive, negative to negative, AC to AC, AC to AC. And let's get them on. So again, we'll just trim our legs. Just lost my solder socket. Now, you can see here that this leg, I have quite a big blob of solder on that, and I've actually slightly over trimmed it. So I'm just going to reflow that. Might as well reflow them all. There we go. Happy with that? And of course, more cleaning required. That is a lot better. Time to test it again. Most important to get the earth screw in, so we'll do that one first. Going to put its opposite number in here. I'll only go with 2 screws for now until we're happy with it. Reconnect the main power board, main power connector. See why that was bent over just a fraction. Do that as well. There we go. I'll put my protective shell back on. I'm not going to put those 2 screws in, but that will be hopefully stable for now. We need our header pins loaded. Now, first things first, before we move on to the oscilloscope, I think we probably ought to just check the voltage with the multimeter. Okay, no explosion. Part 1 complete. No, I'm hearing clicking. I'm hearing clicking, but I am seeing a fluctuating voltage. And the clicking has died down when I've unplugged it. So that could be 2 things. That could be either that's the behaviour under no load, I doubt it, or we are seeing a problem. So the next step is to bring the electronic load back in. So if that click, 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 click I was hearing was purely the fact that it was a switching power supply under no load, then that should go away. We should see 5 volts here and 1 amp draw. If that click, 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 click was a problem that we've introduced, then we should not be able to get an amp. The voltage should die as soon as load starts to be applied. Worst case, we get another bang. So switch is on, cable is in. I'm going to sit back and plug in the mains. Click, 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 reading 0. So unless our connections here were bad, unfortunately, we've introduced a problem. I'll reseat the connections just in case it's at this end. But I suspect, unfortunately, it's much more likely at this point that we've messed up. No, it was a bad connection. 4.9 volts, 1.13 amps. We'll bring that down to 1 amp. The clicking has stopped, by the way. There we go. 1 amp, 4.95. We're a little bit low on the volts there, but it is within 10%. I'd rather that was saying 5.1, but that's at 1 amp, which is, to be honest, a good load on the Falcon. This time we're interested in measuring the ripple. So with the load connected, we'll attach to the oscilloscope. So, same time base as before, and the same 1 volt per division as before. There we go. So we have some ripples, a lot more stable this time. 6.4 microseconds between peaks, 480 millivolts. So we've almost halved the amount of ripple with that recap. We have discovered some very crusty capacitors, which, despite looking okay from the top, had leaked from the bottom. We've cleaned up our board, and with the exception of that one reclaimed capacitor, which I'm not 100% sure is the right voltage, we have completely upgraded our power supply. I'm tempted to tap that voltage and actually measure it to see whether the one there is enough. That's a, I think it was a 16 volt, and the spec was a 30, I think. My suspicion is it probably is. However, that's a reclaimed cap from an old ATX power supply, so I probably want to source a proper replacement for that and change that one again subsequently. So the next step is to screw this all back together and actually try and power the Falcon with it. But for that, I want to make an extension lead for the supply here, because, as you may have seen in my previous videos, the DFB1 development version, here's a DFB1 board, the development version has a lot of debugging headers on it, which makes it too large to fit with the power supply in situ. So with the extension lead and this protector on top, I'll be able to drive it externally, make sure that our upgrade has gone well.